In this session, I'm going to discuss PTSD as a memory disorder. There are a lot of different ways to conceptualize PTSD, but why it's sometimes referred to as a memory disorder is because of deficits that we see in the memory center of the brain called the hippocampus. The hippocampus is a limbic structure, meaning it's classified as an emotional structure of the brain, and it's involved in explicit, declarative, autobiographical memories. So the memories that you can remember. This area of the brain is critical because when memories are consolidated and encoded correctly, then it allows the memories to feel as though they're in the past when you remember them. And they feel less real. They don't feel as though they're happening in the present moment. So before talking a little bit about what happens in the hippocampus during times of extreme stress or trauma, I want to give you a little bit of information about what happens in the hippocampus when it's working perfectly well. So when the hippocampus is working well, it is very online. It is strong. So this is not like the amygdala where, remember, we want to be able to crank that amygdala down. We want it a little less activated after trauma. With the hippocampus, it's actually the opposite. We want the hippocampus fully online, and we want it to be large. So when the hippocampus is working well, it encodes memories well. It is fully activated, and it's almost like it's a camera that takes a panoramic view of the situation. Generally speaking, the hippocampus is most interested in emotional things, emotional events. So if you don't feel anything about a particular situation, you probably won't remember it very well. But when something's emotional, either in a pleasant way or in a distressing way, the hippocampus becomes very interested in encoding this. So when the hippocampus is working well, it encodes these memories by taking a picture, a panoramic picture of the situation. So maybe you had a landmark birthday back in, let's say, August of 2014. And you had this birthday party at a restaurant with all of your friends and a wonderful meal and a big cake. What the hippocampus would do is it would take a panoramic picture of this event with all of the contextual details in it. So it's not that the hippocampus would zoom in the camera and take little snapshots of just the candle or just someone's fork. It takes a picture of everything related to everything else. Also, when the hippocampus is working well, when it takes this picture, it's like a very still camera that takes the picture. So you probably know if you've taken pictures with your cell phone, that if the cell phone's shaky, then you get a blurry picture. The hippocampus takes a very clear picture with all these contextual details. And then what it does is it prints out that picture, which I know is kind of foreign to us now. We rarely print out actual copies of photos anymore. But it's like it prints out this photo, and before it files it away, it turns the photo over, and it puts a timestamp on. And that timestamp tells you when that event occurred. So sometimes Bessel van der Kolk will refer to this area of the brain as the timekeeper of the brain. And because there's this timestamp on this picture, then when it's filed away and you take that file out in the future, that memory will start to feel as though it's getting older. So you'll have this awareness that the memory is not happening right now, but that it happened in the past. Then the hippocampus files this memory away and you go on about your life, maybe until a couple of years later when you walk back into that restaurant and the amygdala, true to form, will come a little bit online and say, what's going on? What is this? Is this dangerous? Have we been here before? Is there something to be scared of? And the hippocampus actually communicates with the amygdala and will tell the amygdala, oh no, everything is okay. I've pulled out the file. This is where we had our birthday party in August of 2014, and remember who was there and the wonderful meal we had and the big birthday cake. And so we have these memories, and of course, for most of us, they're not photographic memories exactly, but they're pretty clear memories with a lot of contextual detail. And as we move through our lives and get older, these memories start to feel a little bit older too. So that would be a well-consolidated memory when the hippocampus is fully online and working well. So then what happens in times of extreme stress or trauma? And what are the errors that can be made? So there's a few different ones. Okay, so first of all, let me say a little bit about why during times of stress, the hippocampus won't fully activate. So if you are in the middle of a very stressful or maybe even a traumatic experience, what happens is the hippocampus will not fully activate. And the mechanism behind this, or the reason that this happens, is actually really clear to scientists. And it's that cortisol floods the hippocampus. So in the last session, when I said a little bit about the amygdala, I said, when it cranks up, when you're experiencing something very stressful or traumatic, one of the things the amygdala does is it sends the body into that stress response, where you might feel muscle tension and your heart racing, for example. But that's not the only type of thing that happens when we get stressed. We also have about 1,400 biochemical and psychophysiological changes that happen in the body in a split second when we become stressed out. One of those chemical changes is that cortisol is released in the brain and the body. Cortisol is a stress hormone, and when we're in a stressful situation and that cortisol floods our system, one of the places it goes is actually the hippocampus. So what most people don't realize is that the hippocampus is the structure that is covered in cortisol receptors. And so when we become stressed, cortisol acts like a magnet to the hippocampus. And when we saturate the hippocampus with cortisol, it can't fully activate. So when it can't fully activate, there's errors that are possible. So one of the errors that can happen when the hippocampus does not fully activate is that instead of taking a panoramic picture of what's happening in a particular situation, we lose the context and the hippocampus takes pictures of small details. This is thought to be adaptive for survival because what it does is it takes pictures of salient or very important details. Details that might be important for your survival now and in the future. But then the cost of that is that we lose the context. And I'll say how that relates to generalization of fear in a moment. So not only do we lose the context, but sometimes what the hippocampus will do is instead of taking a picture of the situation with a very still camera, it takes the picture with a shaky camera and it blurs the picture. So now what you get is very up close pictures of individual maybe faces or items, and we can actually blur them. And when you make a picture blurry and you take away the context, it can be difficult to tell what that picture is. So let me give an example of this, an example of a study that was done many years ago, but that might be familiar to you. It's something that we learn about a lot in school. It was a conditioning study, and it was called the Little Albert study. You might remember this. Little Albert was this toddler. He was maybe 2 or 3 years old. He was brought into the lab, and again, this is many years ago, brought into the lab, and he adored white fluffy bunnies. And the research question was, if we present little Albert with a white fluffy bunny that he loves, and then we scare him while he's in the presence, and we do this over and over again, will he eventually become scared of the white fluffy bunny? Which we could all guess the answer to this is probably yes. So here's how it went. They would bring him into the lab. They would present him with a white fluffy bunny, and then at the moment they would do that, they would make a very loud sound above his head. So maybe a clap sound, except much louder than that. When they would do this, little Albert would start to cry. He would startle and then start to cry. And then they repeated this over and over and over. And sure enough, after a while, the second little Albert saw the bunny, he would immediately begin to tear up. So yes, that conditioning worked. If little Albert's brain had encoded that correctly, meaning if his hippocampus could have fully activated when this was happening, which, by the way, would have been a near impossibility because his hippocampus at that young age is not even developed. But if his brain had been able to encode it properly, it would have gone like this. His brain would have said, okay, when mom puts me in the car seat and takes me to that building and we get out of the car and we go into that lab and there's that guy over there in the white lab coat, when I sit down at that table, in that context, white fluffy bunnies are scary. But in every other context, they're not. So his brain would encode it with full contextual details. Only in this situation are bunnies scary. And he would be very clear that the thing that he needs to be afraid of is white fluffy bunnies, not things that are white and fluffy in general. So that would be proper memory encoding, proper memory consolidation. But that's not what happened with little Albert's brain. And that's not what happens with a lot of our brains when we experience things that are very stressful or traumatic. Here's how little Albert's brain encoded it. His brain encoded it as white, fluffy, dangerous. That's it. Just white and fluffy now is dangerous. So it's a close-up picture of this white fluffy bunny and it's blurred. So the brain does not even really tell at that point that it's a bunny. It just knows that it's something white and fluffy. After that, little Albert became very scared of not only white fluffy bunnies outside of the lab, but he became very fearful of white fluffy bunnies on TV. He became very fearful of white and fluffy Santa Claus beards. So all of a sudden he had this huge fear of white fluffy Santa Claus beards. Couldn't do bubble baths. Maybe he was even scared of a bag of cotton balls because it's white and fluffy. So what's happened with little Albert's brain is something that we call generalization of fear. When the brain takes a fuzzy up-close picture of something, it's no longer just one thing in one context, but it might be 30 different things. And now anything that has one element in common with that feared thing will send the amygdala off, activate it, and there's going to be a perceived threat. So this is oftentimes what happens in memory processing and trauma. The other thing that can happen, another memory error, is that the hippocampus may not only just take up-close pictures and fuzzy pictures of an event, but the hippocampus might also forget to put the timestamp on the memory. If this occurs and the memory is filed away without that timestamp, then whenever a person remembers something terrible that happened, they don't remember it, they actually relive it. So when this happens, they have extreme re-experiencing symptoms, and they might even have a flashback where they feel like it's happening all over again in the present moment. So you can see how errors in hippocampal functioning can lead to arousal and reactivity symptoms, feeling on guard and vigilant and scared because of its relationship to the amygdala, which is getting cranked up, and how it can also lead to those re-experiencing symptoms of PTSD where you feel like an event is happening all over again. And indirectly, it's even linked to those avoidance symptoms of PTSD because logically, of course, you're going to want to avoid anything that activates that memory network ever again because when it is activated, it feels like it's happening all over again in real time. So hippocampal errors are linked to arousal and reactivity symptoms, avoidance symptoms, and re-experiencing symptoms of PTSD. If you're wanting to help the hippocampus, let me give you a couple of tips. So the good news about this area of the brain is that neurogenesis is possible, or the regeneration of neurons. So I always like to put this piece of information near the end of the hippocampus discussion because I don't want you feeling too anxious about it. But what can happen if you experience chronic stress or post-effects of trauma is that not only does that hippocampus deactivate at the time of a traumatic event, but if you remain stressed after that, then that prolonged cortisol saturating the hippocampus can actually lead to atrophy of the hippocampus. And we see in neuroimaging studies, the hippocampus as a structure getting smaller and smaller and smaller. So I know you might be sitting there thinking, oh my goodness, I've been under a lot of stress for 30 years, and the more stress I'm under, the more I have memory problems, and the more I have memory problems, and I'm noticing it, I'm getting more stress, and it can be this vicious cycle. So I always like to tell clients that the good news, the silver lining to this, is that this is an area of the brain where we can regenerate neurons and we can strengthen this area of the brain. And science tells us that this is possible. If you're wanting to strengthen your own hippocampus, here's a couple of tips. The best recommendation is to engage in exercise. So this is going to be maybe 20, 30 minutes a day, about 3 days a week. Don't worry, you don't have to run a marathon to rebuild your hippocampus. It seems that moderate exercise can do it just fine, especially if the exercise that you do involves novel movements. So keep in mind that the brain loves novelty. So if you can engage in novel movements, this might be Tai Chi, this might be dance, this might be yoga, or at least you're looking at something interesting around you. So instead of walking or jogging on a treadmill, just looking at a wall, maybe you get outside and you jog outside and you look around. Exercise has been shown to increase something in the brain called BDNF. That stands for brain-derived neurotrophic factor. And BDNF has been shown to be the thing that actually leads to these neurons regenerating in the hippocampus. And the way we can regenerate is through exercise. A second strategy is going to be meditation. So there's been some research suggesting that meditation increases BDNF in the brain and leads to, again, neurogenesis of the hippocampus. And finally, omega-3s. Incorporating omega-3s in the diet has also been found to increase BDNF. So if you've been stressed for a long time and maybe you notice that your memory's kind of slipping, things are going in one ear and out the other, don't get too stressed about being stressed. Try to have a healthy lifestyle, incorporating those omega-3s, having a good self-care routine, maybe that includes meditation, and get plenty of exercise.